Unit 3, Day 4 notes. Our learning target for today is to measure and classify angles and prove theorems about lines and angles. And actually we're going to use this information to help us prove theorems about lines and angles. So the first thing that we need to take a look at, our first vocabulary for this one, these are adjacent angles. And adjacent angles are two angles, well, two non-overlapping angles that share a vertex, I'm going to say a common vertex and a common side. I'm going to explain a little bit more about that common side in just a moment. First, we're going to take a look at some, it says geometric figure, so some diagrams. So, first of all, non-overlapping. I'm going to show you guys. Here's an angle. And as soon as I put another ray in here, we have 1, 2, 3 angles. But I'm only going to talk about the two small ones, because if I talked about the big one would overlap. Like if I went from the left leg of the big one, or left ray, and went to the right ray, that big angle overlaps angle 1 and angle 2. That can't happen for adjacent angles. I'm also going to throw this in here so you guys can see this. I'm going to say A, B, C, and D. Alright, so for this one, we could say that angle 1 and angle 2 are adjacent. We could also say that angle ABD and angle DBC are adjacent. Those are two possible ways we could say those two angles are adjacent. Now, I said I was going to talk about this common side a little bit more, and the common vertex. Hopefully you all know that the vertex is the point of the V. So the V for each angle, so this is the vertex for this angle. It is also the vertex for the second one. Now, the common side is the side that they share. Both angle 1 and angle 2 have ray BD as a side. And one thing you could do to try to determine whether or not two angles, first of all, have a common vertex, is when you look at their names when they're in letters, look at the middle letter. If the middle letter is the same, you automatically know that you have a common vertex. The other thing that you can do to determine if they have a common side is check if they have other two letters that are the same. Well, here I have BD and DB. So when you look for that ray or that side to the angle, make sure it's between the two angles, and you can see that BD is most definitely between angles 1 and 2. It's between angles ABD and angle DBC. As soon as you see that, you're good. These are adjacent angles. Now, some examples of non-adjacent angles. Now, when I show you these, I'm going to try to progress through these so that you understand completely that we're going to check, do they have a common vertex? If the answer is yes, you check to see if they have a common side. If you can answer yes to both of them, you're in good shape. So, first I will do angle 3 and angle 4. And you can see that angle 3 and angle 4, they do not have a common vertex. Next, I'm going to show you an example of two angles that have a common vertex. And I'll label these 5 and 6. Now, 5 and 6 have a common vertex. Their V's, the points of their V's are at the same place. But notice the sides of 5, it doesn't share any sides with angle 6. So 5 and 6 would not be adjacent angles. And one last one. Let's see, I'll do this one kind of funny. And we'll go 7 and 8. That's supposed to be going a different direction there, just in case you're not sure. For 7 and 8, we answer the question, do they have a common vertex? Again, as soon as you see they do not, their V's are in different places, you're done. These are not adjacent angles. So, example of adjacent up here, examples of non-adjacent angles down here. All right, next we're going to take a look at complementary angles. See if I can zoom in a little bit more here. By zooming in up here a little bit more. All right, right there's as good as we're going to get. All right, complementary angles. These are two angles whose measures add to 90 degrees. They may be adjacent or non-adjacent. We throw that in there because we want people to understand that no matter what, if you have two angles whose measures add up to 90 degrees, they are complements of each other or complementary to each other. So the most common complementary angle that you're going to see, you will see an angle that looks like this that often has the right angle symbol in there because you guys know that right angles automatically measure 90 degrees. So as soon as we put another ray in there, now this not saying that that ray divides it in half, but what we do have is this could be like, say, 27 degrees, and this one down here would have to be 63 degrees. Together they add up to 90 degrees. That's the only way you're ever going to see these. They will always form a right angle, and you're going to have one ray coming out between the other two that make up the right angle for adjacent complementary angles. All others, you might have an angle right here that looks like, it could be like 80 degrees. And then you might have one over here that is 10 degrees. Any combination that will add up to 90 degrees are complementary angles. And we could also say they are complements to one another. So, complementary angles, an example of adjacent complementary, and an example of non-adjacent. Next, we have supplementary angles, and I'm going to try to keep both of these on here. I'm going to try to give you something that might help you a little bit to remember which one goes with which. All right, supplementary angles. These are two angles whose measures add to 180 degrees. Same as before, they may be adjacent or non-adjacent. The most common way you are going to see these, in fact, the only ways that you can see adjacent supplementary angles, you're always going to have a line. It can go in any direction. But then you're also going to have a ray coming off of it, like it might be coming down this way. And you might have one angle 140 degrees and the other one would be 40 degrees. This is a very important concept. This is something that I see many students miss, especially when there's an expression here and an expression here. They come up to me a lot of times and say, Mr. Creaky, I don't know what those two add up to. And I have to ask them, hey, do they form a line? And inevitably, they say yes. And I say, well, how many degrees are in a line? And they say 180. And I go, I kind of make that face like, you said it. And I put my hands up like, you got the information. You know the information. Make sure you know how to use it. So if you have a line, you know that both of those angles have to add up to 180 degrees. Non-adjacent, well, these could be something as simple as like, oh, this angle might be 60, which would mean that this other one over here would have to be 120. Again, any combination of two angles that add up to 180 degrees are supplementary or supplements to one another. Now, I said that I was going to try to give you a nice simple way to know how to remember these, and the way I always think of these and what helped me is that alphabetical order, complement C comes before supplement S. 90 comes before 80. So they go together. C comes first, 90 comes first. S comes second, 180 comes second. So complementary, 90, supplementary, 180. All right. So on to the next page. As we take a look at these, we are asked to tell whether the indicated angles are adjacent. So as we take a look at this first one here, for angle BAC and angle CAD, answer the questions. Do they have a common vertex? Well, I can look at the middle letter and I can see the V's are both at A. So we're good there, and then I can see that we have AC and CA, and I want to go after that and I'm going to look, is that between those two angles? It sure is. So not only do I have a common vertex, I also have a common side. The answer to this one is yes. For EFG and HGF, well, if I look at the letters, I see that F and G are not the same letter in the middle, and that's where your vertex always is. Or if you just looked at the picture, you would see that this V is over here for EFG and the V for HGF is over here. We can stop right there. No, they are not adjacent because they don't have a common vertex. All right. Moving on to C, we have JNM and LNK. You can look, they both have N, so yes, they do have a common vertex. However, JN and NM and LN and NK, the same two letters do not come in the same order in any of them. And if I were to trace this, I would see that one angle opens up and one angle opens down. The only thing they have in common is a vertex. So for this one, our answer once again is no, because it does not have a common side. So remember, when you're trying to determine if they're adjacent, ask the question, do they have a common vertex? If you answer yes, check to see if they have a common side. You have to be able to answer yes to both of those in order for them to be adjacent. All right, example 2A. If we read the instructions for this, I'm not going to slide it over. I'm just going to read them out loud to you. It says name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So I'm going to scoot this up a little bit, zoom out just a tad so that I can have all three of my different types of angles that I'm after. Remember, complementary, and what you might want to do is like go, okay, this is 90, supplementary is 180. So I'm going to look for two angles on here that add up to 90 degrees. So I have 52, 128. Well, that's certainly not 90 degrees. So when I look at 52 and 38, if I add those together, those two angles add up to 90. So what I'm going to do is I'm going to trace. So I'm going to go ABD. So I have angle ABD. And for 38 is BDC. Just a simple way to help me be able to name the angles correctly. Next I have supplementary. They have to add to 180. So 52 and 128, if I check those, bam, right away, I luck out right out of the gate. These two add up to 180. So again, I'm going to trace. Angle 52 is ABD. And the 128 angle is BDE. All right, and then finally for adjacent, I just need two angles that have a common vertex. When I look at B, there's only one angle at that vertex, so I'm going to have to go over here to D. And I can see right away I have 38 and 128, so when I trace those, I have angle BDC. Oops. And angle BDE. Angle BDE. So there, I have my complementary angles, my supplementary angles, and my adjacent angles. Pause for a moment, just make sure you guys have the opportunity to get that. All right, as we take a look at B, we have to do the same thing. So again, you might want to put 90, 180, and then you have your adjacent. We'll take a look at that last then. All right, so complementary, two angles that add up to 90 degrees. Well, 50 and 140 add up to 190, but that's not what I'm after, so I have 50 and 40. All right, so trace angle 50, so DEF. And angle 40 is ABC. Supplementary have to add to 180. Well, I already know that these two don't add to 180, but I know I need 140, so 140 and 40, bam, got it. So I will trace angle 140, so that's angle FEG, and maybe you went GEF, that's a possibility as well. We already know angle 40 is ABC. Finally, we need adjacent angles, and hopefully we see right away that this is the only one that has multiple angles at it, because ABC only has one angle. So I'm going to trace DEF. And the other class did DEG, or A class did DEG. That would not be incorrect. However, I like going after the ones that have numbers in them, so I'm going to go with FEG. All right, hopefully you're doing all right with figuring out complementary, supplementary, and adjacent angles. We're now going to take a look at determining an angle's complement as we take a look at example 3. For example 3, our instructions tell us that angle 1 and angle 2 are complementary angles. Given the measure of angle 1, find the measure of angle 2. So for each of these, since we know they're complementary, you might write 90 degrees by it to help you remember. We know that these two angles have to add up to 90 degrees. Well, if I have one of them, if I subtract it from 90, 90 minus 52 is indeed 38 degrees. I automatically know the measure of the other angle. So, hopefully that's simple and easy for you. Do the same thing with part B in example 3. They give us angle 1 at 12 degrees, so all I have to do is subtract 12 from 90, and that gives me 78 degrees. So the measure of angle 2 equals 78 degrees. Moving on to example 4, we're now going to take a look at supplementary angles, and hopefully you all remember that supplementary means 180. So that means whatever angle they give me, they give us angle 1. All I have to do is subtract that from 180. So I'll go 180 minus 72. That gives me 108. So the measure of angle 2 equals 108 degrees. All right, example 4B, measure of angle 1 is 137. Subtract that from 180. That gives me 43 degrees. So the measure of angle 2 equals 43 degrees. All right, so far so good. Again, I hope we're doing well with complementary and supplementary angles. We're going to bump it up a notch. And with that notch, what we're going to experience now are my two angles are going to be algebraic expressions. That doesn't change the rules at all. For example 5, it tells us that A and B are complementary. Well, that means when I add them together, they have to equal 90 degrees. We have to find the measure of angle A and angle B, and it tells us to show all algebraic work. All right, so this shouldn't be a big deal. I'm going to write down a line that you don't have to write down, but I want you to see what's going to happen. I'm going to go with measure of angle A plus the measure of angle B has to equal 90 degrees. Well, I'm just going to put 90 for now. I'll put the degrees back at the end. You don't have to write this line down when you're doing work for me, but I wanted to use this to show you exactly what's going on. If they're complementary, we add them together and they equal 90 degrees. What I'm going to do now is I'm going to substitute my algebraic expressions in for A. The measure of angle A is x. The measure of angle B is x minus 30. So now my first job, combine like terms if I have them, and I do. I have two x's. So this is going to be x plus x is 2x minus 30 equals 90. Add 30 to both sides to get rid of the 30 on the left. I now have 2x equals 120. Divide both sides by 2. And I get x equals 60. So when I go back up here to put it in, I can say the measure of angle A equals 60. The measure of angle B, and I'm all right with this one. If you go, well, 60 minus 30 is 30. So there we go. Put the degree back in. There are my two answers. All right, moving on to B. Same thing. This time, I'm not going to write down the measure of angle A plus the measure of angle B equals 90 degrees. I'm going to go ahead and just do my 5x plus 4 plus 7x minus 10 equals 90 degrees. Now, when we go to combine like terms on this, since everything is on the left side, I'm not going to do anything to both sides. I go 5x plus 7x is 12x. And 4 minus 10 is negative 6 equals 90 degrees. Combining like terms doesn't mean you're going to add or subtract on, like you would not subtract 4 from both of them. That's a no-no. Just combine them. Read it. 4 minus 10 to get negative 6. All right, from here, we're going to go 12x. I forgot to add the 6 here. So that goes away, plus 6 here. I was doing it in my head already. So 12x equals 96. Now we divide both sides by 12. 12's divide out. 96 divided by 12 is 8. So now I have my value for x. I come back up here and substitute it in. So measure of angle A equals 5 times 8 plus 4. Well, hopefully you know 5 times 8 is 40, plus 4 is 44 degrees. Now there's two ways to do this one. You could also substitute the 8 in, so 7 times 8 minus 10. Hopefully you know that 7 times 8 is 56, minus 10 is 46. The other thing you could have done because you could have just done 90 minus 44 to get 46. Oops, there we go. Leave that there for a sec so you can see that a little bit better. All right. So, to be honest, that's about as complex as things are going to get for these complementary and supplementary, because supplementary would do the same thing except they're going to have to add to 180 degrees. So as we take a look at example 6 and it says supplementary, I'm going to put my 180 right there. And I know that when I add these two together, they have to equal 180. So this time I will have x plus 3x equals 180. Combine my like terms and I get 4x equals 180. Divide both sides by 4. I get x equals 45. Bring that back up here and I get the measure of angle A equals 45 degrees. The measure of angle B equals 3 times 45 to give me 135 degrees. Excuse me. All right. As you can see, I hope that you see that both example 5 and example 6 are almost exactly the same. The only difference is the two angles add to 90 for complementary, they add to 180 for supplementary. All right, so part B to this one, I'm going to do the same thing. 7x minus 3 plus x minus 1 must equal 180. So combine our like terms. 7x plus x is 8x. Negative 3 minus 1 is negative 4 equals 180. So now we add 4 to both sides. You get 8x equals 184. Divide both sides by 8. You get x equals 23. Substitute those values in. So I'm going to try to squeeze them in up here. So the measure of angle A equals 7 times 23 minus 3 equals. Now you know what? I started doing something, and what I should have done is told you guys, hey, when you look at these, which one is easier to put this in? If I put x 23 in right here, this will be 23 minus 1. We know right away that the measure of angle B equals 22 with very little work at all. Now if you put it in up here, 7 times 23 is 151 minus 3 is, oh wait, sorry, it's 161 minus 3 is 158. Now you also could have just done 180 minus 22 and gotten 158. But that's the things that, you need to look at that and determine, hey, that makes sense to me, or I need to put that x in so that I can figure this out. There are shortcuts that you can use. This right here is one shortcut I would absolutely be ecstatic with you using. Because that's demonstrating that you have an understanding of what it means to be supplementary or supplements. All right, example 7. We are asked to find the measure of angle ABD and the measure of angle DBC. Show all algebra work. All right, so for example A here, we're asked to find ABD and DBC. So we need to find these two. Hopefully what you identify is that this is a line, this side is a right angle, which means this is 90 degrees. That means this whole other side, this also has to be 90 degrees, because there are only 180 degrees in a line. that means that 2x plus 3x has to equal 90 degrees. Combine your like terms, you have 5x equals 90, and x, when I divide both sides by 5, x equals 16. So when I substitute those values in, so the measure of angle ABD equals 2 times 16, measure angle DBC equals 3 times 16. So 2 times 16 is 32. 3 times 16 is 48. Hold on. Wait a minute. 2 times 16 is 32. 48. That does not add up to 90 degrees. Should be 18. There we go. 18. So 18 will give me 36. And 54. There we go. Sometimes you got to not trust your notes. And make sure you do the work again. So there we go. 36 and 54. All right, let's take a look at B. Now this is the one I was talking to you guys about when I drew the example for supplementary angles. This is something, anytime you see this, automatically, this is something that I would put a star by it, something that will bring me back here every time so I can see what I did. You might even put it over here to the right of your paper really big so that you can come back and know exactly this is the kind of problem that gives people issues. So we have a line, expression, expression. Well, if I add these two together, they have to equal 180 because this angle plus this angle form a line. So 4x plus 6 plus 11x minus 6 equals 180. So combine your like terms. 4x plus 11x is 15x. And then 6 minus 6, well, that's gone. So I won't even worry about that. Equals 180. So divide both sides by 15. X equals 12. All right, so we substitute this back in up above, and I will have the measure of angle ABD equals 4 times 12 plus 6. That's 48 plus 6, which is 54 degrees. And the measure of angle DBC is 11 times 12 minus 6. 11 times 12 is 132. Minus 6 is 126. Then you can double check, add these together, and I should have told you that over here because 36 plus 54 is 90. That works for that one since that was a right angle. Over here, 54 plus 126 is 180. And that's exactly what we need because we have a line. All right, that's all of the notes for today. If you turn the page, you're going to see that you have some homework to do. So go ahead and get working on that. When you're done, make sure you're ready to check it in and make sure you're doing them right. Oh, by the way, don't worry about linear pairs right now or vertical angles. We'll talk more about that on Unit 3, Day 5.